Now the one I wanted to talk to you about a bit longer is the steps per millimetre. You have a stepper motor in there, it's 1.8 degrees per step, so if you divide that into 360, that's 200 steps. So for the motor to go around once, it's 200 steps. And I'll use the example of a push bike. You're riding your push bike, you have your back wheel, which is, say, the distance you move along the road. Then you have your pedals, and then that goes to your back wheel. If your ratios were 1 to 1, one turn of your pedals would move the back wheel one rotation. This is, and there might be 200 links, let's say, for the chain to move around once. But on here, it's a bit like gears on a bike. You have micro stepping, and that's adjustable, but these are preset for 16, so it divides that step into 16 smaller steps. So to do your calculations, and I add this onto the setup that I'm saving, you have 200 steps by 16 micro steps. This works out to be 3,200 steps for one rotation. On the end of the motor is a gear, and it's got teeth in it. So you count the number of teeth, and that's got 20. So for each rotation of the motor, 20 teeth have gone by. So those 20 teeth are pushing the belt. You have to measure the pitch of the belt one tooth to the other. It's a GT2, which means it's a 2 millimetre pitch. So between each tooth is 2 millimetres. So there's 20 teeth moving 2 millimetres a tooth, so that's 40 millimetres. So you have your steps by micro steps, 3,200. You have your gear teeth by the pitch of the belt, 20 by 2, which is 40. So you just divide 3,200 by 40 and you get 80 steps per millimetre. So to move a millimetre, the software sends 80 steps. So that's for X, Y and Z. Let's come to the extruder. This is where some people have some trouble, and the same thing, it has to feed the filament in at a certain amount, and you fine tune that by the speed when you're extruding, but it has to know how much it's sending. So in this case, there's no belt, but it's the filament, and there is a gear on there. So what I did was I counted the number of teeth, and there's 26. I then got in with the calipers and tried to measure across the teeth. Now, depending if there's a gap or no gap, you may have some trouble. But it was 11 something millimetres. So then I just go to Excel sheet that I made up years ago for calculating the machining dimensions for gears. So this is for the metric gears. So I just put in number of teeth, and then it then shows all the ODs for the different mods. 0.4 mod happened to be 11.2 millimetres. So I know that for a standard gear, that should be 11.2. So if I need to get a replacement, I can. So you have to do your calculations. So instead of 20 teeth by 2 millimetre pitch, we have to use the circumference because we're not moving a belt, and the teeth are only for gripping, they're not pulling anything along. So we just do the circumference of 11.2 millimetre. That's why I use the gear formula to find out what it was. It may be smaller, it may be bigger. That's where the fine tuning comes in. You have 11.2, and if you can remember the old maths from school, 2 pi r or pi d, so it's just pi times 11.2, which works out to be 35.1858, a lot more numbers behind it. So you divide 3,200 by 35.1858, and we get 90.9457 steps per millimetre. So that is the setting for the E extrusion. So we've got 80, 80, 80 for X, Y and Z, and we've got 90.9457 for E, the extruder. If you look at that define statement, it's got the brackets, and you will see there's places for 4. So it's X, Y, Z and E. We just go and highlight that, define steps unit, and we go back to the config, Control V, and there it is. Line 466. It's got 80, 80. Oh no, on mine it's got 80, 80, 94. I changed mine before. So you enter in 80, 80, 80, and for the extrusion, 90.9457. So I'll just do a copy, come back there and paste it in there. Now 90.9457, so that's 90.95. So the error there would be, if you made it 91, it would be 0.05. So on 100 millimetre, you might be only half a millimetre out. So that's the next stage with the extruder, is you actually set it, load up your filament, cut the end off flush, send out 100 millimetre, get your vernier caliper or ruler and measure what it is in millimetres. So if it's 101, you know you're sending out too much, so you have to divide it by 101, and then that will give you a smaller step count. And if it comes out 99, you then divide it by 99, and that'll give you a larger number. So that's how you fine tune the extruder. So you can go no do that now. That's why I've loaded it up, so and that's why I've taken off the tube. So I'll just feed that up, cut it, measure it, and do that. Save this file now, and then you're ready to add power and get started into the proper calibration. So instead of worrying about the silly numbers on the manual or the silly numbers in the config file, it's got nothing to do with our printer really. You've now solved all that problem, and it'll just be a matter of fine tuning. Now we'll just go on to the proper calibration.